Greetings everyone, welcome back to the John Audio Tech Show, where today we're not going to talk about audio, we're going to talk about LED bulbs and their failure modes, what fails inside of them. So over the years I've collected LED bulbs that quit, tore them down, and determined what failed inside. And so far I have 22 of them, and I haven't had that many fail on me. So what I did is enlist my parents to collect LED bulbs that failed at their house, save them for me, and when I come up and visit, I would collect them, bring them home, and tear those down. Now this isn't a scientific test, it's just bulbs that I've collected from around the house of various brands, used in different types of fixtures. However, with those 22 bulbs, I do start to notice a trend forming here of what fails. So without further ado, let's get into it. Okay, to start off is electrical connections. Ignore this, I just have it here for the camera to focus on, otherwise the focus will bounce in and out. So of the 22 bulbs, I have 2 that had electrical connections. So they really didn't fail, they just had a problem with the contacts. However, since most people would not be able to tear a bulb down and figure that out, they would just throw it away and replace it. So what I mean is, when they manufacture these bulbs, this is one that's been torn down, of course, they have the screw base part here and a little button on the end. And what I found was, in some of these LED bulbs, this little button here is just kind of pushed in. If I can get it out there. Okay, so what they do is they run a wire up and fold it over, and then they take this button here. You can see it's hard to handle that, but so what they do is they push that in and it makes electrical contact. So in a couple cases it stopped making contact. It's just, mechanical force. It's not soldered or anything like that. Same thing on this edge. They put this screw base on. You can see it's been dimpled to hold it on to the plastic there. And the wire is just kind of pushed up against it. In a couple cases I found the wire had lost connection with this button contact. So when I took apart the LED bulb, I found that it had lost contact, and I repaired it and the bulb continued to work. I've seen that happen in some CFL bulbs as well, so yeah, it is an issue with that type of design. So the next common failure point in an LED bulb is the driver circuit. And I've broken it out to a subcategory of capacitors, because the capacitor is really part of the driver circuit, but I like to pay attention to how the capacitors perform in those LED bulbs. And I'm actually pretty impressed that of those 22 bulbs, only 2 of them have capacitor failures. So I had 6 driver failures in total, so that means 2 capacitors and 4 failures somewhere else in the driver circuit. Now when I'm talking about capacitors, I'm talking about these electrolytic capacitors. They're usually used to filter the ripple out of the supply voltage to the bulb, or if they're using a switch mode supply, to filter the ripple from the switch mode supply as well. So in the early days of compact fluorescent bulbs, I noticed there were more capacitor failures. So the capacitor manufacturers had to figure out a way to make the capacitor survive in the very hot environment of the bulb. And with later CFLs, and of course now with LED bulbs, it's good to see that capacitors really don't fail that often. What about the rest of the driver circuit? It's a little harder to determine that, but usually if it has a driver chip, sometimes that would have failed, or a driver transistor or something like that. So 6 driver circuit failures out of 22 bulbs, that's a little over 25%. So now we have the next common failure, and that would be the LEDs themselves. And of those 22 bulbs, we had 14. So if my math is any good, we have 22 total. So 14 is about 63%. Way more than half of the failures in the bulbs are the actual LEDs themselves. Now I should mention that they are the SMD type LEDs, the surface mount device here. The little yellow rectangle chips that are often seen in the LED bulbs. I do not have any filament LED bulb failures yet. The filament type of bulbs came out at least 10 years ago, but they weren't very common. But now they're getting pretty common. I haven't used them long enough to have failures yet, but just to be clear, all these bulbs I'm talking about are the ones that use the surface mount type LEDs. Now what the interesting thing is how the LEDs actually fail. And I've come up with my own hypothesis, what I think is going on. I think it's pretty solid, so let me explain what's going on there. Okay, so I made a little drawing here of a surface mount device, packaged LED, and again, that's these little yellow rectangle things you see on the LED board there. So what we usually have is a white package. You can think of it as a shallow bathtub design. Inside here we'll have LEDs. That's these blue long rectangles. They could be oriented this way as well. It just depends on the manufacturer. There could be one, two, or even several LED chips inside these packages. Underneath the packages are the electrodes, and they're bonded on the board using solder paste and heat. So to connect the LED to the electrode, they'll use these little bond wires. So one bond wire will go from the electrode to one end of the chip. The other end will connect to the next chip in the series. Then another bond wire from the end of the other chip to the electrode. Next, they'll pour in this yellow resin. It's actually a clear resin with a yellow broadband phosphor in it. And the blue emitting LED chips with the broadband yellow phosphor will emit white light from the LED package. So what I'm seeing in LEDs that have been used for quite a while, I'm seeing a crack form in this resin material. And using a microscope I can see a crack form along or sometimes branch out. And what I think is happening is because a crack is forming, that means the resin is dimensionally changing in shape and it's splitting apart and pulling these bond wires off. And it's happening at a very small microscopic scale. And it's just enough that you might get some flicker before the light goes out. Sometimes it arcs and burns a spot. You can see here this LED has a burn spot and has quit working. So it might be arcing and burning the resin a bit. Could even be cracking the chip, I don't know. But like I say, this is what I think is happening, is that resin is failing. It's cracking, changing dimensionally, and pulling wires off. Now with my video here, I'm not trying to insinuate that LED bulbs are bad or anything. They've lasted longer than any type of other lighting product that I've used. Now yes, I did have some bad LED bulbs from some brands. I had a group of them that failed within just a few months. It's just because it was a bad product. Especially nowadays, the LED bulbs that I've used are lasting a very long time. Most of the LED bulb types that failed that I'm discussing in my video here, some people call them snow cone. A lot of LED bulbs nowadays look like regular incandescent. This is an LED bulb, this is an incandescent bulb. They look pretty much the same. This is an LED bulb as well. LED bulbs have continued to improve over the last few years. And nowadays you get this style that, like I say, looks just like an incandescent bulb. Has nice light emission. These don't emit light that well downward. A lot of these are dimmable, have high power factor, excellent light quality, also called the color rendering index or CRI. These bulbs here have a CRI of 95. I don't think any LED bulb made today should have a CRI of less than 90. In the earlier days, they were as low as 70. A lot of CFLs were around 70, but nowadays you can get LED bulbs that have CRIs of higher than 90, which is really good. Really like the light quality. Of course, the color temperature, these are 4,000 Kelvin. I wish these were more common. Really nice mid-tone white, not too warm, not too cool, just right, at least to me. So yeah, the video wasn't trying to knock LED bulbs in any way. I just wanted to see what was failing inside of them. So there you have it. That's what I'm seeing with a fairly small sample of 22 bulbs. It'd be nice if I had a sample set of 1,000, but I think you would still see the same trends going on here. As for the future, we'll have to see how the filament style LED bulbs are holding up, what fails in those. But that's going to do it for this one. Thanks for watching.